Now at the moment I'm sending this HTTP request and I'm not doing anything with the response, and I'm also not handling potential errors. That's of course something which we might want to avoid. Now to handle the response and potential errors, I added a new component which you find attached in a zip file, the notification component, which you should put into your UI folder. It's a simple component that displays a title and a message, and that can assume different CSS classes based on a status prop. And then it's simply a little bar at the top which will show up, which can either say something like sending request, or once it's done, it can tell us if it was a success or if we have an error. Now to use it with our current approach in app.js, here on fetch we can simply add then, or we use async await. Since we're in use effect though, we should not add async here, but instead wrap this in a separate function then. And that's actually what I'll do here. So I'll add a new function here inside of use effect, send card data. It's a simple function which will hold this code, but it's now asynchronous. So we can await this to get our response. And then when we get the response here, we can get our response data by awaiting response.json like this. And we can also check if the response is maybe not okay. And if it's not okay, we have an error. So then we might want to throw a new error here where we say sending card data failed or anything like this. If we make it past this line, however, we know that we were successful, and then we know that we, well, should show that success notification. And actually, we also want to show the notification right from the start when we start sending. Now for this, we could import use state and set up some local state in this component, some is loading state and maybe an error state. And we set those states as part of our HTTP request cycle here, and we then use those states to conditionally render the notification component with the appropriate content. We could do all of that, there would be nothing wrong with that, and it would be a good way of handling this. But since we already have a UI slice here in Redux, why not use that? Why don't we add more to the state we're managing here with Redux, and we manage the notification which we're showing with help of Redux now. For this, I'll add a notification property to the initial state, and I'll set it to null initially, so that initially we have no notification. But then we can add a new reducer, which we could call set notification or show notification maybe, where we get our state and where we also use the action, because I expect some action payload here, because the kind of notification that should be shown should be encoded in the action as a payload. And we then therefore set state notification equal to an object, let's say. Of course, the exact structure is up to you since it's your code. But I'll set it to an object where I have a status key, which I expect to get from my action payload. Let's say there we also expect a status property. And status could be something like pending, error, and success. And then we also expect a title, let's say, which we also get from the action payload. And a message, which we also expect as a property on the action payload. So we set our notification to such an object. Now we want to dispatch this show notification action when we start sending the data, when we're done with the data, and if we have an error. So therefore, we can import use dispatch from React Redux to get access to that dispatch function by executing use dispatch. And we import our UI actions from store UI slice. And then in here in use effect, when we send the card data, we initially dispatch UI actions.show notification and pass an object to show notification where we set the status to pending, let's say, because we're currently sending the request, the title to sending maybe, And let's say the message to sending card data. That could be the notification we want to set now. Now, I also want to dispatch an action once we're done. So once we got the response data. I actually don't care about the response data in this case, because for sending the card, I'm not interested in any response. So we don't even need to get the response data. Instead, knowing that we don't have an error is enough. So then I want to dispatch a new notification where the status is success. And it should be success because I'm using that inside of the notification component then to adjust the CSS classes. So I'll set it to success, have a title of success maybe, and then we could say send card data successfully. Now, if we have an error, I also want to dispatch, and I'll do that instead of throwing an error. I'll instead dispatch a new action where I say error, and then have error here as well. And here we could say sending card data failed, like this. Now, this will not handle all kinds of errors though, because we could also have an error from some other part in this code instead of just having an invalid response status. And therefore, I'll actually cut this and go back to throwing an error and simply go below this send card data function, which we defined, execute it here, and then call catch here to catch any errors that might be thrown from inside this function. Since it's an async function, this send card data function returns a promise, so we can call catch on it. We catch any errors we might be getting here, and I then dispatch my show notification action with the error in here. And that then handles all kinds of errors that could occur. Now I'm getting some yellow squiggly lines here because card is no longer the only dependency here. The dispatch function is actually also a dependency now. The dispatch function created by useDispatch. We can safely add it to the dependencies array because React Redux will ensure that this is a function which will never change. So dispatch will never trigger this effect to rerun. Only card changes will. Nonetheless, for completeness sake, we should add it to get rid of these yellow squiggly lines. And now we are dispatching different notification states depending on the current status we have. With all those changes made, we can save this, and we now just need to use this new notification UI state. And I also want to use that in app.js. I already import useSelector, and now I just want to also select my notification status with useSelector from the state. So by drilling into state.ui.notification, I get that notification property, and that's either null initially, or it's an object as set by us, as dispatched by us. And therefore now we can use notification to conditionally render the notification component and to then provide extra data to the notification component. Now for rendering the notification component, I'll start by importing fragment from React because I want to render the notification component side by side to layout. And since adjacent JSX isn't allowed, I'll use fragment and wrap that around layout so that here we can then add notification. And of course, therefore import the notification component, import notification from /components UI notification. And only render notification if we have a notification. So now I'll check if notification is truthy, and only if it is, I render notification. And then I set the status equal to notification.status. I set the title equal to notification.title. And I'll set the message equal to notification.message. With all that done, if we now save that code, I get an error, cannot read property UI of undefined. Yeah, because here I'm using useState. I auto-completed that incorrectly. That should be useSelector. We don't need useState here. So let's switch this to useSelector, save again. And now we have the notification right from the start when I reload. The reason for this is that it initially sends a cart request. If I reload and I have the network tab open, we see there's a cart request being sent to Firebase. So the good thing is we see the pending state briefly and then the success state, so that works. But of course, we don't want to send the cart state right at the beginning, because that will then always override our existing cart on the backend with an empty cart when the app loads. Working around that is simple. In app.js, I just want to make sure that we don't send the cart when this runs for the first time. And for implementing this, we could add a variable here outside of our function, maybe name it isInitial, and set it to true. And I define it outside of my component function so that this does not change and it's not reinitialized if the component renders again. Instead, this will be initialized when this file is parsed for the first time. So when my application started, therefore, and that's exactly what I want. We can use isInitial here to check if isInitial, and if that's the case, I'll return. I'll not continue, so I'll not send my cart data. However, I don't just want to do that, but I now also want to set isInitial to false, so that this will never happen again, but it only blocks this cart data from being sent the first time this effect executes, so when the application started. With that addition made here, if I reload, we don't see the notification, we're not sending that cart request, but if I add something to my cart, we have the pending state and then the success state. And that works just fine. Now let's also test the error state by removing .json and therefore breaking that. If we now save this and reload, if I add to cart, we see the error state. So that is working exactly as it should, and therefore let's bring back .json. Now if we reload, we can send data to the cart again. So that is working, but of course we're never fetching that cart from Firebase, and therefore after a reload we still start with an empty cart again, because we're not using that Firebase data. And of course that's only one way of handling it, putting all that side effect logic into our component. And that's perfectly fine, but there is an alternative, and of course we also want to fetch data. Now before we start fetching data, let's have a look at the alternative of putting all that side effect logic into our component. That is perfectly fine, but we learned that it's only one of the two options. The other option would be the usage of an action creator. And that's something we haven't done up to this point. Or actually, we kind of did. We are using action creators all the time. Something like this here is an action creator. We get those action creators automatically by Redux Toolkit, and we call them to create the action objects which we dispatch. So these are these automatically created action creators. Now we can also write our own action creators, and we can write them to create so-called thunks. Now what is a thunk and why might we want to do that? A thunk is simply a function that delays an action until later, until something else finished. And we could write an action creator as a thunk to write an action creator which does not immediately return the action object, but which instead returns another function which eventually returns the action, so that we can run some other code before we then dispatch the actual action object that we did want to create. This might sound cryptic, but that's a very common pattern and it is easy to implement. So let me show you how it would work. And let's dive into these custom action creators, into these action creator thunks, by moving that code for sending cart data out of the component, though it would be fine there, but to show the alternative, let's move it out of there and let's move it into an action creator. Now for this, I'll go to cart slice because I want to write this custom action creator in that same file, because that is my file for managing the cart. Now to create our own action creator, we can go to the end of that file, after this slice. That's important. So outside of this slice object. And there we can create a new function. Let's maybe name it send card data. Now that is a regular function, and therefore, of course, as always, you could create it with the function keyword as well. And here, let's say we expect the card data. Now we could write this as an action creator by now returning an action object in here. So an object with a type of whatever, and maybe some payload. We never did this ourselves because Redux Toolkit creates these action creators automatically for us for all those reducer methods. Every method in the reducers object receives such an action creator, which is called by using that reducer function name. That's what's inside of these actions here. So we don't need to write such simple action creators on our own. But we could create an action creator which does not return such an action object here, but which instead returns another function. And of course, in JavaScript, you can write functions that return other functions. Now that would be a function that should receive the dispatch function as an argument, and we'll see where this is coming from in a second, and where inside of this function we can then therefore dispatch the actual action we want to perform. Like for example, showing a notification or adding a card item. But before we call dispatch, we can of course do other things. Before we call dispatch, we can perform any asynchronous code, any side effects, because we will not yet have reached our reducer. We're not running this code in a reducer. It's a separate standalone JavaScript function instead. So in our case here, we could go to app.js and actually grab this dispatch action, where we dispatch show notification, copy it, go to the card slice, and execute this in here. Now for this, we need to get access to the UI actions, so I will import them. I'll import UI actions from UI slice, from that folder. If we do that, we can dispatch this action from in here. We can then also copy all that code here for sending the request and handling the response. And I'll not just copy it, I'll cut it. And I'll remove this dispatch code because we also copied that already. So now here we can execute this down here after dispatching that first notification. Now I'm using await here, and the great thing is we can convert this into an async function, this function which we return here. That is fine. Now here we need the card. Here I called it card data. Let me call it card here as well as a parameter so that we do get that card that should be sent. Now in app.js we can now also grab the other code, like dispatching this action here, go to card slice and dispatch that if we make it past this if check. And now when it comes to handling the potential errors, I will actually create a new function, send request here, which is async, and put my code for sending the response and handling the response, so for sending the request and handling the response inside of this function, so that I can call send request here and await that as well, because it's an async function. It returns a promise. And since we're still inside of this outer function, where we also use async, we can use await here as well. And I know that's quite some nesting of functions, but this extra nesting here is required because of how the fetch API works. Because now we can wrap try catch around this await block here and catch any errors that might be thrown from anywhere inside of this function, and then dispatch our error notification as well. So here I'll first of all dispatch success inside of the try block if this succeeds, but if we make it into this catch block instead, I want to dispatch this error case instead. So we'll copy that into this catch block. So with that, what we're doing is we're creating a function, send card data, which immediately, without doing anything else, returns another function, an async function. We don't know yet who will execute that function. but we will soon know it. But in that function, we then dispatch a notification action. Then we create a new function, so yet another nested function, which we create on the fly, which is also async. In there, we send a request. This function is then called by us instead of try catch, simply to handle any errors. If we don't have an error, we dispatch the success notification. If we do have an error, we dispatch the error notification. So now we created this send card data function. How do we now call that function and where? We could of course call it from inside a component, but that's not the idea. Instead, in app.js, in there, I will clean up the content in useEffect. I'll keep useEffect though, but I'll clean up all the code in there. And I'll get rid of my UI actions import. I actually will keep that isInitial code though, where I return and set isInitial to false. I'll keep that. But other than that, I cleaned this up because now I want to do something which might look weird at first. I want to use sendCardData as an action creator. So in app.js, I still want to dispatch after this isInitial check, and I want to dispatch this sendCardData action, so to say. Therefore, I'll export it in card slice, and in app.js, I'll then import it. I'll import sendCardData, so that function which we just exported from store card slice from that file. And then here in useEffect, I dispatch sendCardData, and I'll execute it and pass my card as an argument. Now this might look weird. What we dispatched before always were action creators, so functions, that return an action object with a type and so on. Now in card slice, we are instead dispatching a function that returns another function. But the great thing about Redux when using Redux Toolkit is that it's prepared for that. It does not just accept action objects with a type property, instead it also does accept action creators that return functions. And if it sees that you're dispatching an action which is actually a function instead of an action object, it will execute that function for you. So Redux will execute that function for you. And with that function, I mean this function here. It will give us that dispatch argument automatically so that in that executed function, we can dispatch again. Because this is such a common pattern that we want to have action creators that can perform side effects and that can then dispatch other actions which eventually reach the reducers as part of a flow of side effects or as a flow of steps that should be taken. And that's what we have here. So we can use a function that returns another function as an action as well. That is built into Redux when using Redux Toolkit. So dispatching this here will work. And when we dispatch, Redux will go ahead and it will execute this function for us, and therefore all our other actions will be dispatched and the HTTP request will be sent. So if we save all of that, if we reload here, if I add something to my card, it works just as before. That still works, and Firebase is therefore still being hit, and all the data is still being stored in there. That still works, because that is a supported pattern by Redux. And why would we want to use that pattern? Well, it's simply an alternative to having that logic in your component. You can add that logic in your components. You can stick to the approach we had before. But it's also not a bad idea to keep your components lean, to not have too much logic in them. And at the moment, by moving that logic to this action creator function, we did achieve this. This component is now leaner. It only dispatches one action, not multiple actions. It doesn't care about sending the HTTP request, and all the hard work happens inside of our custom action creator function in our Redux files. And splitting our code like this could be considered good because it keeps our components lean. That does not mean that the other approach is bad. Both options are viable, and that's why I am showing both here.